The sky does not darken, it whitens.
A hard radiation load slams into the upper atmosphere, and within moments, the air above you starts ionizing faster than the planet can absorb it. Satellites fail first, then radio, then the chemistry of the sky itself begins to change. Earth is not being hit by light in any ordinary sense. It is being forced into a new physical condition. The shield overhead is turning into hot plasma, and every layer below it depends on what that layer can still slow, scatter, or survive. If the beam holds, the planet is erased from the outside inward. The first damage is not impact, but transfer. Energy arrives faster than the atmosphere can redistribute it. So the upper layers stop behaving like air and begin behaving like charged material under stress. Electrons are stripped. Molecules break. The sky becomes a working surface where incoming radiation is converted into heat, ionization, and secondary particle cascades. That conversion does not stay contained above you. Each layer that absorbs the load passes part of it downward, changing what the next layer is made of and how it can respond. Protection here is not a barrier. It is a sequence of materials failing in order. What looks like a bright sky is already a chain reaction moving toward the ground. The condition begins above the weather. A concentrated beam of radiation reaches the upper atmosphere and deposits energy faster than the thin air can spread it. The first effect is ionization. Nitrogen and oxygen lose electrons in dense waves, turning the edge of the planet into a charged layer that no longer behaves like stable gas. That change matters immediately. Ionized air absorbs and re-emits energy differently, so the incoming load is not simply passing through, it is being converted, scattered, and multiplied into cascades of secondary particles that drive deeper into the atmosphere. The sky is no longer a passive medium. It has become an active processing layer. As the ionization front thickens, temperature rises sharply. Not in the way sunlight warms the surface over hours, but in a rapid deposition that forces the upper atmosphere into a high-energy state within seconds. Heat transfer accelerates. Pressure gradients begin to form. The first protective layer is already changing its role. You are no longer under a shield that filters radiation. You are under a layer that is being consumed by it. The effect continues downward. Each interaction between incoming radiation and atmospheric particles produces more energetic fragments, electrons, photons, and charged ions, which travel further and collide again. This chain multiplies the reach of the original beam, allowing energy to penetrate deeper than a single pass would suggest. The atmosphere does not stop the beam. It transforms it into a broader field of damage. Electromagnetic systems fail early because the ionized layer disrupts signal propagation. Communication satellites lose stability as charged particle flux interferes with onboard systems. High-frequency transmissions scatter or collapse entirely as the medium carrying them no longer behaves predictably. This is not separate from the physical process. It is the same mechanism, just observed at a different scale. As ionization increases, recombination cannot keep pace. Electrons do not return to their original atoms fast enough to restore neutrality. The charged state persists, and with it, the capacity to absorb more energy. This creates a feedback condition, where the more the atmosphere is altered, the more efficiently it continues to take in the beam's power. The layer is no longer recovering. It is adapting toward failure. Heat continues to build. Molecular bonds begin to break more frequently under sustained energy input. Oxygen dissociates into individual atoms. Nitrogen follows under higher thresholds, and new reactive pathways open as these fragments collide under extreme conditions. Air is no longer chemically stable. It is becoming reactive material. The altitude of maximum damage begins to move downward. As upper layers thin through expansion and loss of structure, the region where energy is most efficiently deposited shifts closer to denser air. This migration ensures that the process does not remain confined high above. It descends. At the same time, the magnetosphere is forced into overload. Incoming charged particles and radiation pressure distort the field, compressing it on the side facing the beam. Normally, this field diverts solar wind and cosmic particles, spreading their impact across a wide area. Under this sustained directional load, it begins to channel energy into specific regions instead. The protection becomes a guide. That guidance drives additional particle streams into the upper atmosphere, reinforcing the cascade already underway. Instead of reducing exposure, the field contributes to concentrating it where the atmosphere is already weakening. Multiple systems are now aligned in the same direction. Transfer increases. From the ground, the change is visible. As brightness without warmth in the familiar sense, the sky carries a hard, uniform intensity. Shadows lose definition as scattering increases. Colors shift as wavelengths are absorbed and re-emitted differently through the altered medium. What you are seeing is not illumination. It is a record of energy being processed above you. The timescale remains short. Seconds are enough for the upper atmosphere to enter a fully ionized state across large regions facing the beam. The transition is not gradual. It is a threshold event where the balance between incoming energy and the atmosphere's capacity to dissipate it is broken. After that point, the process sustains itself. The atmosphere is still present, but it is no longer functioning as a stable, protective layer. It has become the first stage of erasure. The next condition forms at the boundary between sky and surface. Energy that was scattered and multiplied above does not disappear. It continues downward as a dense field of high-energy particles and altered radiation, carrying heat, charge, and chemical disruption into the lower atmosphere. The air you breathe begins to change. Not gradually, but through forced reactions that break and rebuild molecules under load. Oxygen splits more frequently. Nitrogen enters pathways that produce reactive compounds. Ozone layers collapse as formation cannot keep pace with destruction. The composition is no longer stable. As ionization spreads downward, conductivity increases. Air begins to behave less like an insulator and more like a weak plasma. Electrical gradients that would normally dissipate slowly now move faster, forming transient currents through regions that were never meant to carry them. This alters how energy travels. Instead of diffusing evenly, it begins to channel. Those channels guide energy into localized volumes of air, increasing heating rates unevenly. Pockets of intensified temperature form, expand, and merge, creating regions where pressure rises sharply against surrounding layers. The atmosphere is no longer uniform. It is fragmenting into zones under different stress. Heat transfer accelerates through these gradients. Conduction, convection, and radiation all increase, but they no longer balance each other. The rate of input exceeds the rate of redistribution, so temperature continues to climb even as the system attempts to spread it out. This is not warming. It is accumulation. At ground level, surfaces begin absorbing altered radiation directly. Materials respond according to their structure. Darker surfaces convert more incoming energy into heat. Lighter surfaces reflect more. But reflection no longer guarantees safety because the spectrum has shifted into ranges that penetrate or interact differently with matter. The ground is no longer passive. It is entering the same chain of transfer. Water bodies respond first through absorption. The upper layers of oceans and lakes begin to heat rapidly, not just from above, but from penetrating radiation that deposits energy below the immediate surface. This reduces the effectiveness of surface cooling and increases internal thermal gradients. The water is being heated from within. That internal heating disrupts stratification. Layers that were stable due to temperature and density differences begin to mix as expansion occurs unevenly. Local convection intensifies, but instead of distributing heat safely, it brings hotter water into contact with cooler layers, accelerating overall temperature rise. Cooling mechanisms become amplifiers. On land, soil and rock begin storing heat. Thermal inertia slows immediate temperature spikes at depth, but the surface layer responds quickly. Expansion occurs unevenly across materials, generating stress between layers that heat at different rates. The ground is under tension. Electronics fail not only from radiation damage, but from the environment that surrounds them. Increased conductivity in the air alters how signals propagate. Induced currents form in circuits. Components designed for stable conditions experience overload as both internal and external fields shift beyond tolerance. Failure is systemic. This is still the same process that began above. Condition leads to effect. Effect alters material behavior. Material behavior changes how the next effect unfolds. The cascade continues. As atmospheric chemistry shifts, the ability of the air to absorb specific wavelengths changes as well. This feeds back into the incoming beam, modifying how energy is distributed vertically through the atmosphere. The medium is rewriting the path of the energy moving through it. Pressure gradients strengthen. Hot regions expand, pushing against cooler zones, driving winds that are not weather in any ordinary sense. These flows are driven by rapid thermal imbalance, not by solar heating cycles or planetary rotation. The atmosphere is moving under stress. That movement does not relieve the system. It redistributes instability. You remain inside the same environment, but its rules have changed. Air carries charge more easily. Heat moves faster. Chemical bonds break under lower thresholds. Signals do not travel as expected. Every layer is still present, but none of them are behaving as they did before the beam arrived. The planet has not fractured. It has entered a new physical regime. And the conditions that defined a stable world are already being removed. The next condition forms beyond the air you can feel. The magnetosphere begins to compress under sustained particle flux, its boundary pushed inward by the pressure of incoming radiation and charged material. Normally, it spreads incoming energy across vast distances, diffusing impact before it reaches the atmosphere. Now, the load is directional and continuous. That changes how the field responds. Instead of gently deflecting particles around the planet, it begins to funnel portions of that flow along its own structure. Field lines guide charged particles toward the poles and into regions already under ionization stress. Protection becomes routing. The effect is not a single burst. It is a steady injection of additional energy into an atmosphere already saturated with it. Charged particles accelerate along magnetic lines, collide with atmospheric atoms, and generate further cascades of ionization and heat. Condition feeds effect. Effect strengthens the condition. Auroral processes expand beyond their normal limits. Light appears across latitudes that never experience it, but this is not a visual phenomenon to observe. It is a sign that the upper atmosphere is being continuously energized at multiple entry points. The sky is processing energy everywhere it can. As compression increases, the magnetosphere loses volume. Its outer boundary moves closer to Earth, reducing the space available to absorb and redirect incoming particles. The field intensifies locally, but the overall system has less capacity to manage the load. The buffer is shrinking. With less space to spread energy, particle density rises. Higher density increases collision rates in the upper atmosphere, which increases ionization, which increases heat deposition. Each step reinforces the next, tightening the chain of cause and effect. The system is accelerating its own failure. At the same time, reconnection events become more frequent. Magnetic field lines snap and realign under stress, releasing stored energy into bursts that inject additional particles into the atmosphere. These events normally occur in controlled, intermittent patterns. Under sustained pressure, they multiply. Each reconnection releases energy that had been held within the field. That energy does not remain in space. It is delivered downward. The upper atmosphere, already altered, absorbs these injections differently. Ionized layers allow particles to travel further before losing energy, pushing the region of maximum interaction lower than it would be under normal conditions. The altitude of damage continues to descend. You are still beneath an atmosphere. But the layers above are no longer isolating you from what arrives. They are coupling you to it. Electrical currents intensify across the planet. Induced by moving charged particles and changing magnetic fields, these currents travel through the atmosphere and into the ground. Conductive paths form where none existed before, linking sky, surface, and subsurface in a single electrical system. The planet is being wired into the process. Those currents generate additional heat. Resistive heating occurs wherever current flows through material, adding to the thermal load already present from radiation. This heat is not localized to one region. It spreads along the same paths that the currents follow. Energy is arriving in more than one form. Material response changes again. Metals expand and contract under fluctuating temperatures and currents. Structural stresses develop in infrastructure, but more importantly, in the natural materials of the crust where temperature gradients and electrical flow intersect. The ground is not insulated from the sky. As the magnetosphere weakens in its ability to deflect, more of the incoming beam interacts directly with the upper atmosphere, rather than being diverted. This increases the efficiency of energy transfer into the planet system. Less is lost to space. More is absorbed. The distinction between space and atmosphere begins to blur. The boundary that once separated external radiation from internal environment becomes a zone of continuous interaction. Energy, particles, and fields move across it without the previous level of moderation. There is no clean edge anymore. A beam delivers energy. The magnetic field redirects it. Each layer alters the next. The result is not an explosion. It is a system losing its ability to remain a system. The planet is still intact. But the structures that allowed it to remain habitable are now actively transmitting the process that removes those conditions. The next condition reaches the surface as accumulated heat and altered radiation. Energy that passed through the atmosphere and field now interacts directly with land and water, no longer moderated by stable layers above. The rate of deposition remains high, and materials respond according to how they absorb, store, and transfer that energy. Surface temperature begins to rise unevenly. Dark materials convert incoming radiation into heat more efficiently, creating localized zones where temperature climbs faster than surrounding regions. Lighter surfaces reflect more, but reflection is incomplete because the incoming spectrum now includes components that penetrate or interact below the surface. No heat enters the ground. The upper layers of soil and rock expand as they warm, but deeper layers remain cooler for a time. This creates thermal gradients that generate internal stress. Expansion at the surface pushes against more stable material below. The ground is forced into tension. As heating continues, that stress exceeds material limits. Microfractures form, then propagate. Rock begins to crack, not from mechanical impact, but from uneven thermal expansion and contraction under sustained energy input. Structure fails without collision. At the same time, water absorbs energy both at the surface and below. Radiation penetrates into the upper layers of oceans and lakes, depositing heat internally. This reduces the ability of the surface to release energy back into the air, because the heat is distributed through volume rather than concentrated at the boundary. Cooling pathways weaken. Temperature rises through the water column. Density differences that once stabilized layers begin to break down. Warmer water expands and rises. Cooler water is drawn upward and circulation intensifies. But this circulation does not remove heat. It redistributes it. As temperature crosses critical thresholds, phase change begins. Water at the surface transitions into vapor more rapidly. Evaporation accelerates, driven not only by temperature, but by the altered chemical and pressure conditions in the atmosphere above. Mass begins to leave the surface. That vapor does not behave like ordinary humidity. In a charged and heated atmosphere, it participates in further reactions, absorbing energy, dissociating, and contributing to the chemical instability already underway. The hydrosphere joins the cascade. On land, vegetation fails early. Not through burning in the conventional sense, but through rapid dehydration, cellular breakdown, and chemical disruption. Organic material cannot maintain structure under the combined stress of heat and radiation. Biological systems collapse at the molecular level. This is not delayed. It occurs as soon as thresholds are crossed. As surface heating intensifies, air near the ground expands. Pressure gradients strengthen between heated regions and relatively cooler zones. Winds accelerate, driven by thermal imbalance rather than planetary circulation patterns. The atmosphere near the surface becomes dynamic under stress. Those winds do not stabilize the system. They move heat and reactive gases into new regions, extending the area under stress and increasing the total volume affected. Transfer increases again. Electrical activity rises at the surface. With the atmosphere already conductive and currents flowing from above, potential differences develop between ground regions. Discharges occur along paths defined by conductivity and geometry, adding localized bursts of energy to an already overloaded system. Energy arrives through multiple channels. Each channel reinforces the others. Radiation heats. Currents add heat. Chemical reactions release or absorb energy. Movement redistributes all of it. The surface is no longer a boundary. It is an active participant in the process. As temperature continues to rise, materials begin to approach their transformation limits. Organic matter breaks down completely. Water transitions more rapidly into vapor. Rock weakens under sustained stress. Nothing is removed instantly. But nothing remains stable. The key mechanism remains consistent. Condition creates effect. Effect changes material. Changed material alters the next effect. This loop does not stop. It deepens. From above, the beam continues to deliver energy at a rate the planet cannot offset. From below, the surface responds by changing state, feeding new conditions back into the atmosphere. The planet is not shattering. It is being driven out of the range where its systems can maintain themselves. What defined Earth as a stable environment is being replaced by continuous transfer.
And that replacement is still moving inward.
The condition now shifts from layered failure to system exposure. What remains of the atmosphere, the field, and the surface is still interacting, still transferring, but no longer in a way that preserves the idea of a protected world. Each layer has lost its role as a buffer and now acts as a medium for delivery.
Earth is no longer a shielded body. It is an intercepting one. The beam itself defines the environment. A narrow, sustained column of radiation and relativistic particles continues to arrive with directional consistency. This is not diffuse exposure from all sides. It is a focused stream, maintaining alignment over immense distance. That alignment matters, because the energy is not spreading equally across the planet. It is concentrated along a path. Where that path intersects the atmosphere and surface, energy density rises beyond what the system was ever structured to absorb. Away from that path, conditions remain extreme, but comparatively lower. The difference creates gradients not just in temperature, but in the entire state of matter across the planet. Earth becomes unevenly processed. The beam is not simply light. It is a transport mechanism. High-energy photons penetrate and interact with matter, generating cascades. Charged particles follow, transferring momentum, heat, and charge through collisions. Each interaction deposits part of the beam's energy into the material it encounters. Transfer continues with each collision. And because the beam is sustained, the process does not end after initial contact. It repeats. The concept of exposure changes. Instead of a moment of impact followed by recovery, the planet exists inside a continuous condition where energy input exceeds any possible dissipation. There is no interval where systems can stabilize. There is only ongoing load. Under this condition, Earth is no longer defined by its own internal processes. Weather patterns, ocean circulation, and geological cycles lose relevance because their timescales and energy ranges are too small compared to what is being imposed. External forcing dominates. The planet is being driven. As more material is altered, the efficiency of energy absorption increases. Ionized regions, heated surfaces, and reactive chemistry all allow incoming energy to couple more effectively with matter. Less energy is reflected or lost, more is retained and transformed. The system becomes better at being damaged. This is not a separate phase. It is a continuation of the same causal chain. Condition produces effect. Effect modifies material. Modified material increases coupling. Increased coupling intensifies the next effect. The loop is tightening. From a distance, Earth would no longer appear as a stable sphere with clouds and oceans. The illuminated region would show signatures of intense emission, not from reflection of sunlight, but from the planet itself re-emitting absorbed energy across multiple wavelengths. The planet begins to radiate its own stress. This emission does not relieve the system. It is a byproduct of absorption. As outer layers continue to degrade, deeper layers become exposed. The boundary between atmosphere and space weakens further, allowing more direct interaction between incoming beam and underlying material. The gradient that once protected the surface is flattening. There is less separation between outside and inside. Earth is no longer functioning as a layered defense. It is functioning as exposed matter inside a beam path.
That reclassification is critical, because it means the outcome is not determined by a single catastrophic event. It is determined by sustained interaction. The beam does not need to destroy the planet in one moment. It only needs to continue. Given enough time under constant load, the processes already underway will remove the conditions required for a habitable world. Atmosphere thins. Chemistry shifts beyond recovery. Surface materials transition into new states under heat and stress. The system crosses thresholds it cannot return from. Erasure is not a flash. It is a direction. And once Earth is inside that direction, its identity as a stable, life-supporting system no longer applies. It becomes part of the beam's path. The condition extends beyond the surface into orbital space. Satellites that once circled Earth in stable trajectories now move through a charged and heated environment where particle flux alters their materials directly. High-energy collisions disrupt surfaces, degrade shielding, and induce currents through structural components. Their failure is not sudden. It accumulates. Solar panels lose efficiency as radiation damages their crystalline structure. Circuits experience repeated charge surges as conductive pathways form where insulation once held. Orientation systems drift as sensors receive corrupted signals from a sky that no longer behaves predictably. Orbital systems cannot maintain control. Debris begins to form. Fragments from failed satellites spread along their paths, creating additional material that can be struck by incoming particles and re-emit secondary radiation. Each fragment becomes another surface for interaction. The space around Earth becomes part of the process. The beam continues to deliver energy through this region. Particles moving at relativistic speeds pass through orbital altitudes and into the atmosphere, but not without interaction. Collisions with debris and residual gas produce additional cascades, extending the zone of transformation outward. The boundary of the system expands. Earth is no longer the only object under stress. Its immediate surroundings are involved. From this orbital perspective, the directional nature of the beam becomes clearer. It is not washing over the planet from all sides. It intersects at a defined angle, maintaining coherence across distance. The region of highest intensity traces a path through space, intersecting Earth and continuing beyond it. Earth is inside a trajectory. That trajectory determines exposure. Regions aligned more directly with the beam receive higher energy density. Regions offset from it still experience altered conditions, but at reduced intensity. This creates a gradient that spans from space down through atmosphere to surface. The system is structured by direction. As the beam passes through orbital space, it carries momentum. When high-energy particles collide with material, they transfer that momentum, altering motion slightly. For satellites and debris, even small changes accumulate over time, shifting trajectories and increasing the likelihood of further collisions. Motion becomes unstable. Instability increases interaction. More interaction increases energy transfer. The chain continues. At the same time, the thinning of the upper atmosphere changes orbital drag. Under normal conditions, residual air slows objects gradually. Now, with atmospheric expansion and altered composition, drag becomes irregular. Some regions increase resistance, others decrease it, depending on temperature and density changes. Orbits deform unpredictably. Objects that once followed predictable paths begin to deviate. Some descend into denser layers sooner than expected, where heating intensifies. Others shift outward slightly, remaining longer in regions of particle flux and radiation. There is no stable band. The space around Earth loses its ordered structure. Looking outward along the beam, the source remains distant, but its influence is continuous. The same processes occurring near Earth are happening along the entire path, wherever matter intersects the stream. The beam is not an isolated event at Earth. It is a continuous system extending across space. This reframes the situation. Earth is not the center of the event. It is one intercept along a long-range transfer. The energy that reaches Earth was generated far away, accelerated, collimated, and maintained across intergalactic distance before arriving here. The conditions at the source define what happens at the destination. Cause exists far beyond local space, but the effect remains here. As orbital systems fail and debris accumulates, the region around Earth becomes less distinguishable from the atmosphere below in terms of behavior. Charged particles, radiation, and fragmented material move through both regions with fewer differences in how they interact. The separation between space and environment weakens further. You are no longer under a sky that ends. You are inside a continuous volume of interacting matter and energy. The beam does not recognize boundaries. It moves through them, altering each layer according to its material properties, but never stopping. Earth remains within that path. And the process that began above the atmosphere is now fully connected from deep space to the surface, with no layer left that can isolate one from the other. The condition that drives all of this does not begin near Earth. It begins where matter falls. Gas and dust spiral inward toward a supermassive black hole, accelerating as gravity pulls them into tighter orbits. As they compress, friction between particles converts motion into heat, raising temperatures to levels where matter no longer behaves as ordinary gas. It becomes plasma. That plasma does not fall directly inward. It forms an accretion disk, a rotating structure where angular momentum prevents immediate collapse. Within that disk, velocity differences create shear, and shear produces friction, and friction drives temperature higher still. Condition produces heat. Heat changes state. State changes how matter moves. At these temperatures, atoms are fully ionized. Electrons and nuclei move independently, responding not only to gravity, but to magnetic fields generated within the disk itself. Those fields twist, stretch, and reconnect under the motion of charged material. Energy is stored in that structure, and then released. Magnetic fields channel part of the plasma away from the disk. Instead of continuing inward, some material is accelerated along the rotational axis of the system. The result is a pair of narrow jets launched in opposite directions, carrying particles and radiation outward at velocities approaching the speed of light. The beam is not emitted. It is constructed. Acceleration occurs through electromagnetic processes. Charged particles spiral along magnetic field lines, gaining energy as they move. Collimation keeps the flow narrow, preventing it from dispersing as it travels outward. Direction is maintained. That direction is what reaches Earth. The energy delivered to Earth is therefore not random. It is the output of a system where infalling matter is converted into directed motion and radiation. The efficiency of that conversion determines the intensity of the beam. Higher infall rates produce stronger output. Stronger output increases reach. The beam carries both photons and particles. Photons deliver energy through electromagnetic interaction, penetrating and scattering through matter. Particles deliver energy through direct collisions, transferring momentum and generating secondary cascades. Two mechanisms, same result. Energy arrives and must go somewhere. As the beam travels, it does not lose coherence quickly. Because it is collimated, its spread over distance is limited compared to an isotropic source. This allows it to maintain significant intensity across intergalactic scales. Distance reduces intensity, but not enough to prevent consequence. By the time it reaches Earth, the beam has already interacted with intervening material. Interstellar gas, dust, and magnetic fields alter it slightly, but not enough to remove its structure. It remains a directed stream, carrying the signature of its origin. The cause is preserved in the effect. Back at Earth, that preserved structure defines the condition. The direction, intensity, and composition of the beam determine how energy is deposited across atmosphere, surface, and orbital space. Every interaction on Earth traces back to processes occurring near the black hole. Local damage is governed by distant mechanics. This connection is continuous. There is no break between source and effect. Material falls inward. Energy is generated. Fields accelerate particles. Particles and radiation travel outward. Earth intercepts the flow. Energy is transferred. Material changes. The chain is unbroken. The planet does not need to be near the black hole to experience its influence. It only needs to lie along the path. And once it does, the conditions at the source dictate the conditions at the destination. The beam does not weaken into harmless light before it arrives. It remains a working process, still capable of transferring energy, still capable of driving the same sequence of effects. Earth is not reacting to a distant object. It is responding to an active system whose mechanism is still running. And that system does not pause because it has reached a planet. The condition within the beam is not uniform. It contains structure. Particles do not travel as a smooth flow. They move in streams within the stream, guided by magnetic fields that twist and shift as the jet propagates outward. Regions of higher density form, followed by regions of relative sparsity, creating fluctuations in how energy is delivered along the path. Transfer is uneven. Where density increases, collision rates rise. Higher collision rates mean more energy is deposited over shorter distances when the beam encounters matter. When those denser segments intersect Earth, the rate of heating and ionization increases beyond the already elevated baseline. The load pulses without stopping. These pulses are not separate events. They are variations inside a continuous process. As relativistic particles move through the beam, they interact with magnetic fields and emit additional radiation. This radiation extends across a wide spectrum, including high energy ranges that penetrate deeper into materials before interacting. Energy arrives in layered forms. Each layer interacts differently. Some wavelengths are absorbed quickly in the upper atmosphere, contributing to ionization and heat. Others pass further, depositing energy lower in the system. Particles follow their own paths, colliding, scattering, and generating cascades that multiply the effect. Multiple channels operate at once. At Earth, this layered structure becomes visible through consequence. Regions already under stress experience sudden increases in heating as denser portions of the beam pass through. Chemical reactions accelerate, electrical currents intensify, material failure rates increase. The system does not stabilize between these increases. It compounds them. The beam also carries angular structure. Particles spiral along magnetic field lines, introducing rotational motion within the flow. When this rotating structure intersects matter, it alters how energy is distributed spatially, creating patterns of deposition that are not purely radial.
Energy does not spread evenly outward. It follows the geometry of the field. This geometry matters at planetary scale. It determines where the highest stress accumulates, how gradients form, and how different regions of Earth respond relative to one another. The beam shapes the damage. As the jet travels across immense distance, it interacts with intergalactic medium. Sparse gas and weak magnetic fields slightly scatter and reaccelerate particles, modifying the beam's internal structure without dispersing it entirely. These interactions maintain the complexity of the flow rather than smoothing it out. The beam remains active. By the time it reaches Earth, it is not a simple column. It is a dynamic system, carrying variations in density, energy, and direction within its overall alignment. That dynamic nature ensures that no part of the planet experiences a constant condition. Instead, each region cycles through slightly different states of stress as internal structures of the beam pass through. Variation increases instability. At the same time, the overall direction remains fixed. The beam continues to intersect Earth along the same path, ensuring that the cumulative effect grows over time even as local conditions fluctuate. Consistency drives accumulation. This combination is critical. Fluctuation prevents equilibrium. Consistency prevents recovery. Together, they remove any possibility of stabilization. Back within the atmosphere, these variations translate into shifting zones of ionization, heating, and chemical change. Regions that begin to recover are immediately driven back into instability as new segments of the beam arrive. The system cannot reset. The same applies at the surface. Localized heating intensifies, relaxes slightly, then intensifies again, each cycle pushing materials further from their original state. Repeated stress accelerates transformation. Nothing returns to baseline. From a broader perspective, the beam is not simply delivering energy. It is imposing a pattern. That pattern originates in the structure of the jet near the black hole and persists across distance, encoded in the motion and interaction of particles and fields. Earth is responding to that pattern. Every fluctuation in the beam produces a corresponding fluctuation in planetary conditions, linking the smallest changes in the source to observable effects at the destination. Cause and effect remain connected at every scale. The planet remains inside the stream. And the stream continues to carry not just energy, but structure, direction, and variation, all of which define how the process of erasure unfolds over time. The condition expands beyond a single beam into a governing structure. The jet is not an isolated feature. It is sustained by a continuous supply of matter falling inward, converting gravitational potential into heat, motion, and directed output. The quasar exists as long as that supply continues. Input determines output. At the center, the accretion disk does not operate alone. It is fed by larger-scale flows of gas drawn from the host galaxy. Clouds of material lose angular momentum through collisions and interactions, allowing them to move closer to the core, where the same process of compression and heating begins again. The engine is part of a network. That network spans the galaxy. Stars evolve, eject material, and enrich the surrounding medium. Gas collects in regions of higher density, moves under gravitational influence, and eventually contributes to central inflow. Each step transfers matter inward, feeding the disk that powers the jet. Local processes build global consequence. The beam that reaches Earth is therefore the end of a chain that begins across thousands of light years. Material distributed through a galaxy becomes concentrated, accelerated, and directed outward again in a narrow stream. The path reverses. Infall becomes outflow. This reversal defines the quasar. It is not simply a bright object. It is a system that takes in matter over large scales and returns part of that energy as directed radiation and particle flow. Conversion governs everything. That conversion is efficient. A small amount of infalling mass produces a large amount of energy, far exceeding what normal stellar processes generate. This allows the jet to maintain intensity across vast distances. Energy density remains high, even far from the source. Earth intercepts that density. The implication is structural. The planet is not uniquely targeted. It lies along a line defined by processes that began long before it existed and will continue after it is gone. Alignment determines consequence. Within this framework, the idea of safety changes. Distance alone does not protect. Direction matters as much as separation. A planet far from the source can still experience extreme conditions if it lies within the path of the jet. A planet closer but outside that path may remain unaffected. Geometry defines exposure. This reframes the earlier events. The atmospheric ionization, surface heating, and orbital disruption are not separate disasters. They are local expressions of a continuous system operating at galactic scale. Effect is the local form of a larger process. At the midpoint of this understanding, the subject shifts. The event is no longer Earth being destroyed by an external force. It is Earth being processed by a system that converts matter into directed energy across space. The beam is not an attack. It is an output. That output follows physical laws that do not account for planets, life, or stability. It is governed by gravity, motion, and electromagnetic interaction at scales where Earth is simply another intercepting body. The system does not recognize worlds. It only transfers energy. Once Earth is inside that transfer, every layer responds according to its material properties. Atmosphere ionizes, surface heats, structures fail, and the planet shifts into a new state defined by continuous input. The process is consistent. And it will continue as long as the source continues to feed the jet. The midpoint realization settles. Earth is not the subject. It is part of the path. The condition extends outward into the host galaxy that feeds the source. Gas does not arrive at the central black hole in a single flow. It moves through large-scale structures, drifting, colliding, compressing, and losing angular momentum over time. Each interaction transfers energy, changes direction, and pushes matter closer to the core. Motion becomes inward supply. That supply is uneven. Regions of higher density contribute more material, increasing the rate of infall. When inflow rises, the accretion disk heats further, magnetic fields intensify, and jet output strengthens. More input increases output. Less input reduces it. This creates variability at the source. The beam that reaches Earth is not constant in absolute terms, even if it remains continuous. Its intensity reflects conditions across the galaxy that determine how much material is being delivered inward at any given time. Distant structure shapes local consequence. Within the galaxy, feedback occurs. As the jet carries energy outward, it interacts with surrounding gas, heating it, pushing it, and in some regions preventing further collapse. This reduces future inflow in those areas, altering the long-term balance of supply. Output modifies input. The system regulates itself.
But regulation does not mean safety. It means adjustment. At Earth, this adjustment appears as variation in the beam's intensity over time. Periods of slightly lower energy input may occur, followed by increases as supply conditions change at the source. The process never stops. It shifts. Back along the path of the beam, interstellar medium absorbs a fraction of the energy. Gas clouds heat, expand, and change state as particles and radiation pass through them. Some regions become less dense, others more turbulent, altering how future material moves within the galaxy. Energy redistributes matter. Matter alters future energy flow. This interplay maintains the system. From Earth's position inside the beam, these large-scale adjustments do not reduce the fundamental condition. Energy continues to arrive at a rate far above what the planet can dissipate. Local response remains dominated by incoming load. Atmospheric remnants continue to thin. Surface temperatures remain elevated. Orbital space stays unstable. Each of these is a direct continuation of the same chain. Condition at the source determines beam structure. Beam structure determines energy delivery. Energy delivery determines material response. Material response alters subsequent interactions. The sequence repeats without interruption. At this stage, the distinction between cause and effect becomes less immediate in perception. The origin lies far away. The consequence remains here. But the connection is continuous. Earth does not experience a delayed echo. It exists within an active flow. As long as the galaxy continues to feed its central engine, the jet remains active, and the conditions at Earth remain governed by that activity. Time at the source becomes time at the destination. The planet cannot exit the process on its own. It cannot reduce the input. It cannot redirect the beam. It cannot restore the layers that have already changed. All local mechanisms operate within limits that have already been exceeded. The only variable that could end the condition lies at the source. And that source is sustained by processes spanning the entire galaxy. Earth remains within the path. And the system that placed it there continues to operate, carrying energy across space and depositing it wherever alignment allows. The condition now depends on alignment rather than distance. The beam does not expand uniformly in all directions. It remains confined within a narrow angular spread maintained by magnetic collimation and relativistic motion. This creates a corridor through space where energy density remains high, while regions outside that corridor receive far less. Exposure becomes geometric. Angle determines intensity. If Earth sits directly within the central axis of the beam, energy arrives with minimal dispersion. If it lies slightly offset, intensity drops rapidly as the beam's profile falls away from its core. Small changes in direction produce large changes in effect. This is not gradual protection. It is threshold behavior. Inside the corridor, conditions exceed planetary tolerance. Outside it, conditions may remain within survivable ranges. There is no intermediate safety zone. As the beam propagates, slight deviations occur due to interactions with interstellar and intergalactic media. Magnetic fields and density variations can bend or scatter portions of the flow, altering its exact trajectory over long distances. Trajectory is not perfectly fixed, but it remains stable enough. These small deviations shift the corridor across space over time. Regions that were once outside the highest intensity path may move into it, while others move out. Alignment is dynamic.
At Earth, this dynamic alignment introduces variation. If the planet sits near the edge of the beam, intensity may fluctuate as the core shifts slightly relative to its position. These fluctuations alter how energy is deposited across the planet, changing gradients of heat, ionization, and stress. Position within the beam matters continuously. Rotation adds another layer. As Earth turns, different regions move into and out of the highest intensity zone. The beam does not follow the planet. The planet moves through the beam. Motion redistributes exposure. Regions facing the beam receive direct load. Regions rotating away experience reduced but still significant secondary effects as energy continues to circulate through atmosphere and surface. No region is isolated. Orbital motion extends this further. Earth's path around the Sun changes its position relative to the beam over longer timescales. This shifts the angle of intersection, potentially moving the planet deeper into or further out of the corridor. Trajectory determines duration. If alignment persists, exposure continues. If alignment shifts, intensity changes. But while Earth remains within any significant portion of the beam, the process does not reverse. The geometry defines the outcome. This reframes the earlier destruction. It is not simply that the beam is powerful. It is that the planet occupies a position where that power is delivered efficiently. Efficiency drives consequence. From a wider view, the beam cuts through space like a narrow path of sustained transfer. Most of the surrounding volume remains unaffected, while anything intersecting that path experiences the full chain of effects. Space is not uniformly dangerous. It is selectively so. Earth happens to be in the path. That placement is not intentional. It is a result of motion, orientation, and the relative positions of systems separated by vast distance. But once that placement occurs, the consequences follow inevitably. The beam does not adjust. The planet does not resist. Energy continues to arrive along the same direction, shaped by the geometry of its origin and the structure of its propagation. And as long as that alignment holds, Earth remains inside a corridor where its systems cannot recover, only continue responding to the incoming load. The condition extends across time as well as space. The quasar does not turn on for moments. It persists for intervals measured in millions of years, sustained by the continuous infall of matter into the central engine. During that period, the jet remains active, carrying energy outward without interruption at scales that dwarf any planetary timeline. Duration becomes force. At Earth, the effects unfold in seconds and minutes. Atmosphere ionizes. Surface heats. Systems fail. But the source operates on a scale where those changes are instantaneous. The difference in time scale matters. A planet measures stability through cycles, days, seasons, geological processes that repeat and balance over time. The quasar does not operate on those cycles. It maintains a condition that does not allow equilibrium to return. There is no recovery window. Even if intensity fluctuates slightly, the baseline remains far above what Earth systems can absorb. Temporary reductions do not restore the atmosphere or cool the surface. They only slow the rate of change before it resumes. Time does not heal under continuous input. The longer the alignment holds, the deeper the transformation becomes. Atmospheric loss continues. Heated gases expand. Escape velocity thresholds are crossed more easily as particles gain energy, and the upper layers begin to thin, not just through chemical change, but through physical loss into space.
Material leaves the planet. That loss is cumulative. Surface water continues to transition into vapor, then into dissociated components under radiation. Hydrogen escapes more readily, reducing the total mass of the hydrosphere over time. The planet dries from above. Rock, once stable, continues to absorb heat and undergo structural change. Over longer durations, melting becomes possible in regions where energy deposition remains high enough to sustain elevated temperatures. The crust begins to alter its state. These changes do not require a single extreme moment. They require persistence. Persistence is what the quasar provides. At the source, the process continues without regard to distant consequence. Matter falls inward, energy is generated, jets are maintained, and the beam remains active as long as supply persists. The mechanism does not pause. At Earth, this translates into a condition where every second extends the same chain of cause and effect further into the planet's structure. Each moment adds to the total change. The concept of instant erasure becomes clearer. It does not mean the planet disappears in a flash. It means the systems that define it as habitable are removed on timescales far shorter than those systems can adapt. From the perspective of life, it is immediate. From the perspective of matter, it is continuous. Time connects the two. As exposure continues, the distinction between initial damage and long-term transformation fades. There is no clear boundary between phases, only a steady progression driven by constant input. The process does not step. It flows. Earth remains within that flow. And because the source operates over durations far exceeding any planetary recovery process, the outcome is determined not by a single event, but by sustained exposure that carries the system further away from its original state with each passing moment. The condition now redefines what it means for a planet to be habitable. Habitability is not only temperature and water. It is exposure. A planet can hold oceans, maintain an atmosphere, and orbit at a stable distance from its star, yet still fail if it lies inside a persistent energy corridor like this. External input overrides internal balance, and the systems that regulate climate and chemistry lose control. Balance depends on isolation. Earth once had that isolation. The atmosphere filtered radiation. The magnetosphere diverted charged particles. Distance from extreme sources limited incoming energy to levels the system could manage. Those conditions are no longer present. With the beam intersecting the planet, external forcing exceeds internal regulation. The processes that once stabilized temperature, pressure, and composition now operate under loads they were never designed to handle. Stability is not broken by complexity. It is broken by magnitude. Magnitude comes from sustained transfer. As atmosphere thins and chemistry shifts, the ability to maintain pressure declines. Lower pressure changes boiling points, alters gas behavior, and further destabilizes the remaining system. Each change feeds into the next, reducing the range of conditions under which equilibrium is possible. The stable window narrows. At the same time, incoming radiation continues to alter molecular structure. Complex compounds break down into simpler forms. Organic chemistry cannot persist under continuous high-energy exposure. The pathways that once supported biological systems are replaced by reactions driven purely by energy input. Chemistry becomes forced, not selective. This reclassification extends beyond Earth. Any planet placed within such a beam would undergo the same sequence. Atmospheric ionization. Surface heating. Chemical breakdown.
Material transformation. The specifics vary with composition and structure. The outcome remains consistent. Exposure determines state. From a broader perspective, habitable zones are not fixed regions around stars. They are conditional environments, defined by both local and external processes. A planet may meet all internal criteria and still fail if external input changes. Habitability is temporary. It depends on remaining outside destructive systems. In this case, Earth has moved, or the beam has aligned, so that the planet is no longer outside. It is inside. That shift removes the conditions required for life faster than those conditions can be restored. The atmosphere cannot rebuild while it is being stripped. The surface cannot cool while it is being heated continuously. Recovery requires reduced input. Input has not reduced. The chain continues. At this stage, the idea of Earth as a self-sustaining system is no longer accurate. It is a system under external control. Energy arrives. Material responds. State changes. And those changes are governed not by the planet's own processes, but by the persistent conditions imposed from far beyond its orbit. Earth is no longer defining its own environment. It is receiving one. And that environment does not include stability. The condition widens beyond a single galaxy into the structure that feeds it. Galaxies do not exist in isolation. They move within larger gravitational networks, exchanging material through interactions, mergers, and tidal forces. These processes deliver gas inward, replenishing the reservoirs that eventually reach central black holes. Supply is not local. It is distributed across scales. When galaxies pass near each other, gravitational forces distort their shapes, pulling streams of gas and stars into extended arcs. Some of that gas loses energy through collisions and falls toward galactic centers, increasing accretion rates. Interaction increases inflow. Inflow increases output. This means the quasar phase is not only a property of one galaxy. It is tied to the environment in which that galaxy exists. Clusters of galaxies, bound by gravity, create conditions where such interactions are more frequent. Material is exchanged, compressed, and redirected, feeding central engines across multiple systems. Energy generation becomes a network effect. The beam that reaches Earth originates within that network. Its existence depends on matter that has moved through intergalactic space, been captured by a galaxy, transported inward, and converted into directed output by the black hole at the center. Cause extends far beyond the source. At Earth, the effect remains the same. Energy continues to arrive. Material continues to change. But the origin of that energy now includes structures spanning millions of light years. This reframes the scale of influence. The beam is not only a product of a black hole. It is the outcome of matter flowing through cosmic structure. Flow determines accumulation. Accumulation determines output. Output defines the beam. Within this wider view, Earth's position becomes even less central. The planet is a small intercept within a process driven by interactions between galaxies and the distribution of matter across space. Local consequence is tied to distant structure. As the beam travels through intergalactic medium, it encounters extremely low-density gas and weak magnetic fields. These interactions are subtle compared to those within a galaxy, but over vast distances, they influence the beam's shape and stability. Propagation is shaped continuously. The beam does not move through empty space.
It moves through a medium that slightly alters it at every step. Yet its coherence remains. By the time it reaches Earth, it still carries enough energy and structure to drive the processes already underway. The intervening distance has reduced intensity but not removed function. Distance modifies. It does not neutralize. Back on the planet, the consequences remain governed by the same chain. Energy input exceeds dissipation. Material changes accumulate. Systems lose stability. The difference now is understanding where that chain begins. It begins not at the atmosphere, not at the beam's arrival, but in the movement of matter across cosmic structure, funneled through galaxies and into engines that convert it into directed energy. Earth sits at the end of that funnel. And the conditions it experiences are the final stage of a process that spans from intergalactic flow to planetary transformation, with no break in the sequence connecting them. The condition now extends into the structure of space itself. Matter does not move randomly across the universe. It follows filaments, long gravitational channels where galaxies, gas, and dark matter concentrate. These filaments guide material toward nodes where clusters form and interactions become more frequent. Flow becomes organized. That organization determines where energy is eventually produced. Galaxies within these filaments receive a steady supply of gas from their surroundings. Over time, this inflow sustains star formation, feeds central black holes, and maintains the processes that can generate quasars. The network feeds the engine. The engine feeds the beam. This places the origin of the beam within a larger pattern. The quasar is not an isolated event. It is a node within a cosmic web, converting inflowing matter into outward energy. Earth lies along one of those outward paths. At this scale, the distinction between source and environment becomes less clear. The black hole, its host galaxy, and the surrounding filament all participate in the same process of moving matter and energy across space. Boundaries dissolve into flow. The beam is one expression of that flow. As it travels, it carries energy across regions that otherwise experience very little interaction. Intergalactic space, often described as empty, becomes a medium through which this directed transfer occurs. The emptiness is structured. At Earth, the consequences remain immediate. Atmosphere continues to thin. Surface remains heated. Material continues to change. But now those changes are understood as the final stage of a process that began across cosmic distances, guided by gravitational structure and sustained over immense time. Condition at the largest scale determines condition at the smallest. The planet does not experience an isolated disaster. It experiences the endpoint of a networked system. This perspective alters the idea of rarity. A quasar beam intersecting a planet is uncommon, not because the mechanism is unusual, but because alignment within this vast structure is precise. The beam must remain coherent, the planet must occupy the path, and the timing must overlap. When those conditions meet, the process is inevitable. Geometry and timing converge. At this its state is defined by its position within the network and its intersection with the beam. Position determines condition. The planet continues to respond. Energy arrives. Material changes. Structure weakens. The chain remains unbroken. From cosmic filament to galactic core, from accretion disk to relativistic jet, from beam to atmosphere, from atmosphere to surface, each stage transfers the same process forward. Earth is simply the last stage currently in view. And as long as it remains within that path, the system continues to operate through it, carrying the consequences of a vast structure down into the smallest details of matter on the planet. The condition now reduces to what remains when the transfer continues long enough. The atmosphere has thinned beyond recovery. What is left no longer behaves as a stable gas layer, but as a sparse, heated envelope where particles escape more easily than they return. Each incoming pulse of energy adds velocity to molecules that no longer remain bound to the planet. Loss becomes the dominant process. With reduced pressure, heat transfer changes again. There is less material to carry energy through convection, so radiation becomes the primary mechanism. Surfaces absorb and re-emit energy directly, without the buffering effect of a dense atmosphere. The surface is exposed. Temperature gradients flatten across regions aligned with the beam. Where the energy arrives most directly, surfaces remain under sustained heating. Where alignment is weaker, temperatures still remain elevated because redistribution processes have already spread energy globally. There is no cool side. Water has largely transitioned. What remained after initial heating has either escaped as vapor or been broken into constituent elements under radiation. Hydrogen, being lighter, leaves more readily, reducing the total mass of what once formed oceans. The planet loses its volatile components. Without those components, regulation fails completely. There is no medium left to absorb heat efficiently, no cycle to redistribute it, no system to return conditions toward equilibrium. The system has no restoring force. At the same time, continued particle impact alters the surface directly. High-energy collisions break atomic bonds in minerals, creating defects in crystal structures and changing how materials conduct heat and electricity. Over time, this leads to further changes in how energy is absorbed and emitted. Material properties shift. Shifted properties increase coupling. Energy is retained more effectively, driving temperatures higher and accelerating further transformation. This feedback loop continues as long as the beam remains active. The surface adapts toward instability. Deeper layers begin to respond. Heat conducted inward accumulates over time, raising temperatures below the surface. While this process is slower than atmospheric or surface change, persistence ensures that even these regions cannot remain unaffected. The planet changes from outside in. Orbital space is largely cleared of stable systems. Most artificial objects have failed, fragmented, or descended into the atmosphere. The region around Earth no longer contains ordered motion, but a diffuse distribution of material interacting with incoming radiation. The environment has lost its structure. Throughout all of this, the same chain continues. Energy arrives. Matter absorbs. State changes. New state absorbs more. There is no interruption. The concept of Earth as a planet with layered protection, stable chemistry, and self-regulating systems no longer applies. It has been replaced by a body undergoing continuous external forcing with no mechanism left to counter it. Erasure becomes clearer. It is not the disappearance of the planet. It is the removal of the conditions that defined it. Atmosphere is reduced. Water is lost. Chemistry is altered. Surface is transformed. Each of these is a direct consequence of sustained energy transfer. The beam does not need to intensify. It only needs to continue. And as long as it does, the remaining material of Earth will keep responding, moving further away from its original state,
until what remains can no longer be recognized as the same system that once supported life. The condition now becomes quieter. Not because the process has slowed, but because the structures that once amplified change are no longer present. Without a dense atmosphere, without active weather, without complex chemistry cycling through layers, the system simplifies into direct interaction between energy and matter. Transfer becomes more immediate. Incoming radiation reaches the surface with fewer intermediaries. There are still particles, still collisions, still secondary cascades, but fewer layers remain to transform and redistribute the load before it arrives. What once passed through multiple stages now interacts almost directly with exposed material. The chain shortens, but it does not weaken. Surface materials continue to absorb energy and re-emit it. Radiative balance shifts toward higher equilibrium temperatures because there is little left to carry energy away. With reduced mass in the atmosphere, there is less capacity to store and transport heat. Retention dominates over redistribution. The result is steady elevation. Temperatures no longer fluctuate through familiar cycles. They stabilize at levels determined by continuous input and limited output. Regions facing the beam maintain higher values, but even regions offset from direct alignment remain far above previous conditions due to accumulated energy within the planet. There is no return to baseline. At the same time, particle interactions continue altering surface composition. High energy impacts displace atoms, break bonds, and rearrange structures. Over time, this leads to the formation of new material states, not through slow geological processes, but through repeated energetic collisions. The surface is being rewritten. These changes affect how the surface responds to further input. Altered materials may absorb more efficiently or emit differently, changing the balance of energy transfer. Each modification feeds into the next interaction, maintaining the progression. Cause continues to shape effect. With most volatile components gone, the remaining mass of Earth becomes more dominated by heavier elements and stable compounds. This changes density distribution, thermal properties, and the way energy moves through the interior. The planet's composition shifts. Internally, heat continues to conduct inward. Though slower than surface processes, this transfer accumulates over time, raising temperatures in deeper layers and altering long-term structural behavior. The change is not confined to the surface. From orbit, the planet would appear altered in both emission and structure. Instead of reflecting light, it emits across a range of wavelengths determined by its elevated temperature and ongoing interactions. The signature of the planet becomes one of active energy exchange rather than passive reflection. It becomes a source, not by its own generation, but by what it absorbs. The beam still intersects. The source still feeds it. The system still operates. Nothing about the larger chain has changed. At this stage, the absence of familiar processes becomes as significant as the presence of destructive ones. Without atmosphere, without water, without biological activity, there are fewer interactions to mediate or complicate the flow of energy. The system simplifies toward directness. Energy arrives. Matter responds. State adjusts. The loop persists. The idea of erasure becomes more precise. It is not only that Earth has lost its previous conditions. It is that what remains follows a different set of rules, governed almost entirely by external input and basic material response. The planet is no longer a complex system resisting change. It is a simpler system accepting it. And in that simplification, the process becomes more efficient, continuing to drive the remaining material further from its original state with each passing moment. The condition now allows a final reclassification of what Earth is within the beam. It is no longer a world undergoing damage. It is a material body inside a continuous energy stream. That distinction removes the last layer of interpretation. There is no longer a sequence of disasters. There is only sustained transfer. Incoming energy continues to deposit across the surface and into the remaining structure of the planet. Without atmosphere or active chemical buffering, absorption and emission define the entire interaction. Input sets state. State sets response. What remains of the surface continues to adjust toward equilibrium under this input, but the equilibrium itself is defined by the beam, not by internal balance. Temperatures, material phases, and structural properties settle only as far as the incoming energy allows. There is no independent stability. As the process continues, mass distribution begins to shift subtly. Loss of lighter elements alters the ratio of materials within the planet. The outer layers become increasingly composed of heavier, more stable components, changing how energy is absorbed and conducted. Composition follows exposure. Internally, heat accumulation continues. Over long durations, conduction raises temperatures in deeper regions, modifying internal gradients that once drove geological processes. Those processes no longer operate in familiar ways, but the energy they depended on has been replaced by external input. Internal change continues without internal control. From a distant perspective, Earth is no longer distinguishable by the features that once defined it. There are no cloud systems, no oceans, no reflective patterns associated with atmosphere. Instead, there is emission. The planet radiates energy absorbed from the beam, its spectrum shaped by its altered material state. The signal it sends outward reflects not its original composition, but the conditions imposed upon it. It becomes a response, not an origin. Along the beam, other intercepts may exist. Gas clouds, dust regions, or other bodies intersecting the path undergo similar processes, each responding according to its own material properties. Earth is one example among many. The process is general. It does not require a planet. Any matter within the path will be altered. This removes the final sense of uniqueness. The outcome is not specific to Earth. It is inherent to the interaction between directed energy and material systems. At this stage, erasure is no longer a future event. It has already occurred in functional terms. What defined Earth as a habitable system has been removed. What remains is matter continuing to respond. The beam persists. The source continues to feed it. The structure that created this condition remains active across scales far beyond the planet. And Earth remains within that structure. Not as a world, but as a point where energy continues to pass through matter, carrying the consequences of a distant system into a place that no longer retains the properties it once had. The condition now reaches its simplest form. Energy enters. Matter responds. Nothing else is required. The beam continues along its path, unchanged in purpose, unchanged in structure, carrying the same process across distance. Earth remains within that path, but no longer as a system that can resist or transform the incoming load into stable cycles. It only absorbs and emits. The balance between those two is set externally. Incoming energy defines temperature. Temperature defines emission. Emission never exceeds input. The state stabilizes only within those limits. Across the surface, material phases settle into forms that can persist under constant exposure. Some regions may partially melt, then hold that state as long as energy input remains steady. Others remain solid but altered, their structure changed by repeated collisions and heating. Stability becomes conditional. It depends entirely on continued forcing. If the beam were removed, the system would begin to evolve again under its own processes. Cooling would occur, materials would shift, new gradients would form. But the beam is not removed. So the condition holds. From a distance, the planet becomes part of the beam's visible structure. It contributes to the overall emission pattern along the path, a localized increase where additional matter intercepts and reprocesses the flow. Observers far away would detect this as variation in intensity along the jet, not as a separate world. Earth merges into the signal. This is the final stage of reclassification. Not destruction. Not disappearance. Integration. The planet is no longer an independent system. It is a component within a larger one. The same way gas near the black hole becomes part of the accretion disk, and part of that disk becomes part of the jet, Earth becomes part of the beam's interaction with matter. Different scale. Same process. The chain remains consistent across all levels. Matter enters a system. Energy is transferred. State changes. Output reflects that change. Earth has entered that chain at the point of interception. And once inside, it follows the same rules as every other part of the system. There is no reversal within the process itself. Only continuation. As long as the source feeds the beam and the beam intersects the planet, the interaction persists, holding Earth in this state where it no longer defines its own conditions. It only responds to them. And in that response, it becomes indistinguishable from the flow passing through it. The condition returns to where it began. Not as a sky, but as a boundary that no longer exists. At the start, the atmosphere carried the load. It ionized, heated, and failed in sequence, passing energy downward through layers that once defined the separation between space and surface. That separation is gone. What remains is a direct path. Energy travels from deep space to the surface without interruption, interacting only with what matter is left to receive it. There is no filtering layer, no buffering gradient, no system that can slow or reshape the incoming flow into something stable. The path is open. And it stays open. The beam continues along its trajectory, carrying the same structure, the same variations, the same directional force that began near the black hole. Earth remains inside that trajectory, but no longer as a distinct system resisting it. Only as matter within it. The idea of seconds becomes relative. From the perspective of the process, erasure occurred the moment the balance broke. The time it takes for atmosphere to thin, for water to leave, for surface to change, is simply the unfolding of that broken balance. The outcome was set early. Everything after is continuation. At the scale of human experience, the change is immediate. The systems that supported life fail in moments compared to the timescales that created them. The difference between formation and removal is not symmetrical. Creation is slow. Removal can be sustained. Sustained input does not need speed. It needs persistence. The quasar provides that persistence. Far away, matter continues to fall inward, feeding the engine that drives the jet. Magnetic fields continue to accelerate particles. Energy continues to be directed outward along narrow paths that cross space for immense distances. The system remains active. Nothing about its operation changes because of what happens at Earth. The planet does not alter the beam. The beam alters the planet. And once that alteration has progressed far enough, there is no remaining mechanism that can restore the original state. The conditions required for a habitable world have been removed, not by a single event, but by continuous transfer that replaced them. The sky that once defined above and below has been replaced by a flow that does not recognize direction in the same way. There is no above. There is only incoming. The ground that once supported stable systems now exists within that same flow, responding directly to it without mediation. There is no shelter. There is only exposure. Earth remains, but not as it was. It exists as matter inside a path defined by distant structure, sustained by processes that do not stop, and governed by conditions that do not return to equilibrium. The place you would have called a world is no longer a place. It is a point in a continuous transfer that never needed it to begin with. The condition extends forward beyond what remains, not into recovery, into continuation without reference. The beam does not end at Earth. It passes through, carrying the same structure onward into space beyond. What was absorbed has already changed the planet. What continues onward will interact with whatever lies further along the path. Transfer does not stop at interception. It continues past it. This removes the last sense of finality. There is no endpoint where the process concludes at Earth. The planet was never the destination. It was one location along a trajectory defined long before it existed. The path extends indefinitely. At the source, matter continues to fall. Infall drives heat. Heat drives acceleration. Acceleration maintains the jet. At the destination, matter continues to respond. Absorption drives change. Change drives new states. New states alter future absorption. The chain remains active on both ends. Between them, space carries the connection. This connection is not fragile. It persists across immense distance, maintained by the same physical laws at every point along the path. There is no region where the beam forgets what it is. It remains consistent. Earth no longer defines anything within this chain. Its role has been completed. The atmosphere that once processed incoming energy has been removed. The surface that once moderated heat has been transformed. The internal gradients that once supported dynamic systems have shifted. What remains is stable only in the sense that it follows the imposed condition. And that condition continues. From a distant perspective, there is no event to mark. No explosion. No sudden disappearance. Only a change in the way matter interacts with incoming energy at a specific location along a beam. That change is permanent as long as the condition persists. If the beam were to shift, if alignment were to break, the planet would begin to evolve again under its own processes. Cooling, recombination, and new gradients would form over time. But those processes would begin from a different state. The previous system would not return. The memory of oceans, atmosphere, and biological complexity would exist only in the arrangement of matter that no longer supports them. Even absence has a structure. For now, the beam holds. And as it does, Earth remains within a system that does not pause, does not recognize boundaries, and does not require a world to justify its existence. It only requires matter along its path. And it continues to find it. The condition settles into a form that no longer needs to change quickly. Not because the process has ended, because it has reached a state where change continues without visible thresholds. Energy still arrives. Matter still responds. But the responses are now incremental. Surface materials adjust slowly under constant input, shifting structure over extended time rather than through rapid transitions. Without volatile components or layered systems to amplify change, the planet evolves through direct interaction alone. The pace becomes steady. Not gentle, just uninterrupted. Temperature remains set by the balance between incoming energy and outgoing emission. That balance no longer fluctuates widely. It holds within a narrow range defined by the beam's intensity and the surface's ability to radiate. Equilibrium exists, but it is imposed. Internally, heat continues to move. Gradients smooth out as conduction distributes energy deeper into the planet. The difference between surface and interior decreases over long durations, altering how the planet stores and releases heat. The interior adjusts to the same condition. There is no separate regime below. From orbit, the planet's signal becomes consistent. Emission stabilizes into patterns that reflect its altered composition and sustained temperature. Observers would not see a dynamic system of clouds and weather, but a steady source shaped by external forcing. Variation fades. Consistency remains. Along the beam, similar transformations occur wherever matter is present. Gas clouds shift state. Dust heats and disperses. Other bodies, if they intersect the path, follow their own versions of the same sequence. The process repeats across different materials. Each instance is local. The system is universal. At this stage, the idea of Earth as a unique case dissolves completely. It is one example among many of how matter behaves under sustained directional energy input. Its history as a habitable world is no longer part of the active system. Only its current state matters. And that state is defined by the beam. The connection to the source remains. Matter continues to fall into the black hole. Energy continues to be generated. Jets continue to carry that energy outward. Nothing in that chain has altered. The planet remains within it. And because the chain does not depend on Earth, it does not respond to what Earth has become. The process continues with or without any change in the planet's structure. This is the final reduction. A world becomes matter. Matter becomes response. Response becomes part of a larger flow. No step requires recognition. No step requires awareness. Only continuation. And as long as the beam remains aligned, that continuation holds, carrying the same condition forward through time, across space, and through whatever matter lies along its path next. The condition now extends beyond what can be measured locally. Not because instruments fail, because the system no longer centers on the planet at all. The beam continues through space, maintaining structure, carrying energy, and interacting wherever matter exists. Earth does not define the system's scale, and it no longer provides a meaningful reference for understanding it. The reference has moved outward. Far beyond the planet, the jet remains coherent. Particles continue to travel at relativistic speeds, guided by magnetic fields that preserve direction over immense distances. Along that path, small interactions accumulate, shaping the beam without breaking it.
Propagation remains active. At each point, the same sequence occurs. Energy arrives. Matter absorbs. State changes. The repetition is exact. This repetition is what gives the system its scale. Not size alone, but consistency. At Earth, what once felt like a singular event now appears as one instance of a pattern that exists everywhere along the beam. The processes that removed atmosphere, altered surface, and redefined the planet are not unique. They are standard outcomes. The difference lies only in material. Different compositions produce different intermediate states, but the governing chain remains identical. No matter what intercepts the beam, the same logic applies. Condition defines response. Response follows material limits. Limits are exceeded. From this perspective, Earth becomes interchangeable. Not in identity, but in behavior. Any similar body placed within the same path would undergo comparable transformation. The specifics might vary, but the direction would not. The system does not adapt to the object. The object adapts to the system. This inversion completes the shift. The planet no longer defines its environment. The environment defines the planet. And the environment is not local. It is a directed structure extending across intergalactic space, maintained by processes that operate continuously and independently of any single intercept. As long as matter continues to feed the source, the beam continues to carry energy outward. As long as the beam continues, anything within its path remains subject to the same chain. There is no final stage within the process itself. Only ongoing interaction. At Earth, what remains has already settled into that interaction. There is no further transformation required to reach a stable state under these conditions. What continues now is maintenance of that state through constant input and response. The system has reached continuity, not an end. A steady expression of the same laws applied without interruption. And within that expression, Earth no longer stands apart as a world with its own defining properties. It remains as matter inside a path, participating in a process that extends far beyond it and continues whether it is present or not. The sky was the first boundary. It carried the load, changed state, and passed everything downward until there was no difference left between above and below. That was the beginning of erasure. Not the loss of the planet. The loss of the layers that made the planet a world. What remains is still there. Mass, structure, orbit. But none of these define what Earth was. The atmosphere is gone as a system. Water is gone as a cycle. Chemistry no longer selects for life. Each of those was removed by the same process. Energy arrived. Matter responded. The response replaced the original condition. And once that replacement began, it did not reverse. Far away, the source continues. Matter still falls. Energy is still produced. The beam still moves. Nothing about that system required Earth. Earth only needed to be in the path. And once it was, the outcome followed. The place that once felt fixed under your feet was never fixed. It was a temporary balance between incoming energy and internal response. That balance is what defined the world. And it can be removed. Not by impact. Not by explosion. By continuity.
A direction held long enough becomes a condition. And inside that condition, a world becomes matter again.